Salam, peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase. One continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them the three dimensions show themselves at once. Time as omega, omega, space as kappa, kappa, and motion as nu, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. We focus on one essential component of the epistemic firewall: why rules persist. Part 47 asks a civilizational question. Why do some rules survive across generations, while other rules fade, break, or get replaced? This matters because science is not only about finding a rule once. Civilization needs rules that keep coming back, even when people, instruments, and cultures change. So the skill you gain today is the persistence test. How to tell the difference between a rule that is truly about reality and a rule that is only about a particular procedure. Before we build the test, we repeat the axiom of episode 11, because it is the spine of the firewall. Rules do not become real by elegance, consensus, or tradition. They earn a license only by surviving falsification, variation, independence, and scope discipline. And when a rule fails, we do not believe harder. We tighten, downgrade, or retire its license. Now let me teach persistence as a story you can see in your mind, even with your eyes closed. Imagine you are walking through a huge landscape at night with a lantern. The landscape is not made of hills and trees. It is made of possible rules. Each place in this landscape is a different constraint you might try to use to explain what you measured. This landscape is what we call rule space. In rule space, there are two kinds of places that matter most. Some places are like a needle standing on its tip. The needle can stand for a moment. It looks impressive. It looks precise. But one small breath makes it fall. These are fragile rules. They can fit one dataset perfectly, yet collapse as soon as anything changes. Other places are like a deep valley. You can walk toward the valley from many directions, over many paths, and you still end up down at the same floor. These are stable rules. They do not survive because you protected them. They survive because the structure of reality keeps pulling you toward them. A persistent rule is valley-like. A non-persistent rule is needle-like. Persistence is not oldness. It is not fame. Persistence is stability under change. So what does change mean in the firewall? We do not mean changing the facts to make a rule look bad. We mean changing the honest way you look, changing the time regime you observe, the spatial sampling you use, and the motion context you place the phenomenon in. In holophase terms, we mean shaking omega, kappa, and nu together. Here is the simplest definition, spoken plainly. A rule is persistent only if it stays admissible when we vary time, space, and motion in licensed ways, and when we vary our representations and pipelines without cheating. Now we build this carefully. First, we anchor ourselves in holophase. Holophase begins with one primitive, phi, the holophase field. It is not a substance, it is not a particle. It is a continuous, cyclic movement. Everything else we talk about is a shadow of how phi changes. We speak the basic dependence as phi of x and t. That means phi depends on position x and time t. From phi, we read the triunity. Time as omega. Omega equals d phi over dt. This is the rate at which phi turns as time passes. Space as kappa. Kappa equals d phi over dx. This is the rate at which phi changes as you move through space. Motion as nu. Nu equals omega divided by kappa. This is the motion readout that connects time rhythm to spatial structure. And now the key discipline. Omega, kappa, and nu are not three separate worlds. They are three coupled echoes of one changing phi. You cannot test a rule in only one echo and call it persistent. A rule must survive as a triunity constraint. Now, why do rules fail to persist? Because many rules are not boundaries of phi. Many rules are boundaries of method. A community can share the same textbooks, the same instrument designs, the same calibration habits, and the same analysis software. Inside such a shared culture, a rule can look strong simply because everyone is asking reality the same narrow question in the same narrow way. That is social persistence. It is not structural persistence. Then a new instrument arrives, or a new data set arrives, or a different culture measures the same phenomenon with a different representation, or a new pipeline becomes possible. Suddenly, the old rule collapses. People say, reality changed. The firewall answers, no, your method changed, so your method-made rule disappeared. That is why persistence matters. It protects civilization from confusing procedure with reality. Now, how do we test persistence in a disciplined way? We need three ingredients: windows, representations, and pipelines. A window is written W. A window is the slice of reality you actually observed. Your duration, your time resolution, your spatial region, your spatial resolution, and your motion context. In triunity words, W determines what omega you can see, what kappa you can resolve, and what nu you can infer. A representation is written R. Representation is the language you use to describe the same measurements. Time domain versus frequency domain, spatial grid versus spectral basis, different coordinate choices, different smoothing choices, as long as they stay within license. A pipeline is written pi, pronounced pi. Pipeline is your step-by-step procedure that turns raw measurements into an inferred rule, filtering, estimating, fitting, validating, and reporting uncertainty. Now listen carefully. Persistence does not mean the rule survives only one W, one R, and one pi. Persistence means the rule keeps reappearing across many W, many R, and many pi within declared scope. So the firewall asks a simple question. If we make small license changes in W, R, and pi, does the inferred rule change only slightly in a predictable way inside uncertainty? Or does it jump into a different identity? This is what people mean by structural stability. But we can say it in everyday language. A persistent rule still looks like itself after you shake it. Now let me give you the shake in 3 clean moves, one for each echo. Shake 1, the omega shake. Change your time window. Observe for a shorter duration. Observe for a longer duration. Change the rhythm you sample at within license. A persistent rule may become noisier when the window is too short, and clearer when the window is longer, but it does not become a different rule. Shake 2, the kappa shake. Change how you sample space. Use a different geometry. Use a different resolution. Change coarse graining, meaning average more or less. Regrid the same region. A persistent rule can be translated across these samplings, within uncertainty. A fragile rule disappears when you zoom or regrid. Shake 3. The new shake. Change motion context. Change the frame you use. Change the propagation setting. Change coupling conditions within scope. If a law survives only in one special frame, it is not persistent. It is a frame-dependent procedure. And now the critical holophase correction. These shakes are coupled. Changing the omega window changes what kappa patterns you can resolve and what new relations you can infer. Changing kappa sampling changes temporal coherence needs and therefore changes new estimation. So the true persistence test shakes omega, kappa, and nu together as one woven fabric. Now we add 2 more shakes, because civilization does not fail only in time, space, and motion. Civilization also fails in representation and pipeline. Representation shake. Describe the same data in a different licensed representation. If the rule only appears in one representation, it might be a lens artifact. Pipeline shake. Let different pipelines analyze the same raw data. If only one pipeline finds the rule, that is suspicious. If many pipelines converge, that is a strong persistent signal. So now we can state the simplest classification in the world. A reality-dependent rule depends on Phase structure. A procedure-dependent rule depends on your pipeline habits. Fit is not enough. Many rules can fit. Persistence is the upgrade test. Now I will give you the persistence battery as 7 checks, spoken in a simple order. Check 1. Scope discipline. Where exactly is the rule claimed to hold? A rule must state its omega range, its kappa regime, and its nu context. If it has no scope, it has no license. Check 2. Representation independence. Does it appear across more than one licensed representation of the same measurements? Check 3. Omega variation. Does it survive time window and rhythm changes within license? Check 4. Kappa variation. Does it survive spatial sampling and coarse graining changes within license? Check 5. Nu variation. Does it survive different motion contexts and frames within scope? Check 6. Pipeline independence. Do different teams or different software routes converge on the same constraint family within uncertainty? Check 7. Instrument model robustness. Does it survive reasonable calibration updates? If a tiny calibration change erases the rule was inside the instrument. If a candidate passes most of these checks, it earns a stronger license. If it fails, it must be narrowed, downgraded, archived, or retired. Now we enforce the holophase energy demotion rule, because persistence must also appear in the ledger. Energy is not a substance. Energy is accounting. It is a tally derived from coherence or mismatch in omega, kappa, and nu patterns. So a persistent rule should yield energy tallies that remain meaningful under method change. The bookkeeping labels can change, but the balance relation should reappear. We say the ledger equation out loud. E total equals E1 plus E2 plus ... plus En plus R. E total is the measured total tally under the licensed window. E1 through En are component tallies defined by the admitted constraint family. R is the residual, the leftover mismatch. Now the persistence test for the ledger is simple. The absolute value of R stays less than epsilon. Epsilon is the declared uncertainty bound. If R stays small across license variations of W, R, and pi, the accounting is stable. If R explodes when you swap pipeline or representation, the rule was balancing the books only inside one bookkeeping culture. And there is an even deeper honesty the firewall sometimes demands. Sometimes you cannot define energy coherently in a regime because tri-unity coherence cannot be stabilized. If omega or kappa cannot be estimated stably, then nu is unstable, and any ledger becomes representation dependent. In that case, the firewall requires you to say, energy accounting is not licensed in this regime yet. That is not weakness, that is sanity. Now the firewall requires an explicit prediction and an explicit falsifier. Prediction, spoken plainly and tied to omega, kappa, and nu. If a rule is structurally persistent, independent groups using different licensed instruments and different licensed pipelines will converge on the same omega, kappa, nu constraint family within uncertainty. In simple words, if the rule is real, different honest paths lead to the same valley floor. Falsification, spoken plainly. If a rule survives only under one narrow pipeline, one culture of hidden assumptions, or one instrument model, and fails under licensed variation, then the claim of broad persistence is false. The rule is procedure dependent. More sharply, if independent groups repeatedly infer incompatible omega kappa nu constraints beyond declared uncertainty, the persistence claim breaks. When the persistence claim breaks, the firewall does not argue, it acts. License consequences are simple. If a rule persists, the firewall strengthens its license. It widens scope, tightens uncertainty, and raises standing. Widen scope means the rule is allowed across broader omega regimes, broader kappa samplings, and broader nu contexts. Tighten uncertainty means repeated convergence justifies smaller error bars. Raise standing means future claims must respect this constraint unless they show a licensed reason to challenge it. If a rule does not persist, the firewall downgrades it. There are 4 actions. Narrow. Keep it only inside the omega, kappa, nu region where it survived. Downgrade to local fit. Treat it as useful in that regime, but not a deep constraint. Archive as transient. Store it as a failed candidate so others do not repeat the same failed search. Retire. Remove it from active use when it repeatedly fails. And now I repeat the axiom again, because people are always tempted to cling. When a rule fails, we do not believe harder. We tighten, downgrade, or retire its license. Now I want to slow down and make the valley image even clearer, because this is the heart of persistence. Picture 2 explorers walking in the same mountain range, but at different times of year. One walks in summer, one in winter. The paths look different, yet both explorers, if they follow gravity, still end up in the same valley. That valley is not created by opinion, it is created by the shape of the land. In the firewall, the shape of the land is the structure of phi, as revealed through omega, kappa, and nu. Different cultures may have different instruments and different mathematics, but if the constraint is structural, disciplined inference keeps sliding back toward the same valley floor. A persistent rule is not a tradition, it is a repeated correction. Reality keeps pulling you back. So the core revelation of part 47 is this. A rule persists when it is not merely fit to data, but structurally stable in rule space. Fit to data is not enough, because flexible rules can imitate truth. A flexible rule is like wet clay. You can press it into the bumps of one dataset and feel proud. But when you move to a new place, the clay shape no longer matches. The firewall rewards survival under change, not beauty of fit. Here is a short, concept-first story. Imagine a young scientist working late at night. She wants to see a perfect curve. She tries one filter. The curve is messy. She tries another. It looks better. She adjusts a threshold. It looks beautiful. She feels she has found a law. The firewall does not accuse her of lying. The firewall says, you may have discovered the constraint, or you may have trained the rule into existence. Only persistence can tell the difference. Now we make scope concrete. Scope answers, Where does this rule live? Every rule lives somewhere. It lives inside omega regimes, inside kappa regimes, and inside new contexts. A scope claim that is too wide is like claiming a boat can sail on land. It will fail, not because boats are useless, but because the claim was dishonest. So the first step of persistence is always write scope down in tri-unity language. The second step is uncertainty. Uncertainty is not weakness. It is honest precision. A rule that pretends to have zero uncertainty is usually hiding dependence on method. That is why we used epsilon. Epsilon is the uncertainty bound that tells you how much the rule can bend without becoming a different rule. Now we name the common enemy, overfitting. Overfitting is when a rule learns noise and calls it law. Overfitting often looks like genius because it fits perfectly. But it fails the moment you change W, R, or pi. Overfitting is needle-like. Persistence is valley-like. Now I give you a clean operational protocol you can remember. Step 1. Declare what you measured as phi sentences. Local, measurable snapshots of phi patterns in your licensed window. Step 2. Declare the window W. Duration, resolution, region, and motion context. This prevents hidden scope. Step 3. Declare the representation R. Time domain or frequency domain. Spatial grid or spectral basis. And any smoothing or transforms that are licensed. Step 4. Declare the pipeline pi. Filtering, estimation, fitting, validation, and uncertainty. Step 5. Infer the candidate constraint family in omega kappa nu language. Step 6. Vary method within license. Adjust W, swap R within allowed translations, and swap pi by using an alternative pipeline or another team. Step 7. Ask whether the same constraint family keeps reappearing within uncertainty, or whether it fractures into incompatible families. Here is a simple convergence trial. Take one dataset. Keep the raw data fixed. Give it to 3 groups. Each group uses a different pipeline and, if needed, a different licensed representation. All groups declare scope and uncertainty. If the inferred constraints cluster, you have a valley. If they scatter, you have needles. Now a subtle point. Persistence does not require the exact same surface language. One group may express the constraint in time domain, another in frequency domain. If these are licensed translations of the same omega kappa nu constraint family, persistence is still present. Real constraints should survive translation. If a law disappears when rewritten in an equivalent representation, it is not a law of phi. It is a property of your coordinate choice. Now return to energy, because energy is where many false intuitions hide. Energy is not a substance. Energy is accounting, a tally of coherence or mismatch in omega, kappa, and nu under the admitted rule family. This is why persistent rules produce persistent accounting. The balance relation keeps reappearing even when bookkeeping style changes. Now I will give you 3 levels of persistence in everyday language. Level 1, local persistence. The rule survives small variations, but only inside a narrow omega kappa nu band. Useful, but local. Level 2, cross-method persistence. The rule survives different representations and different pipelines, and survives wider variation in omega, kappa, and nu. Stronger license. Level 3, civilizational persistence. Different institutions and traditions still converge on the same constraint family. Strongest persistence before we test scale. Finally, remember, persistence is not stubbornness. Persistence is the rule refusing to die when you stop protecting it. The scientist must be flexible so reality can show what remains. Now we return to the night landscape of rule space. Some rules are needles. They stand only when you hold your breath. Some rules are valleys. They keep pulling inquiry back. Rules persist when they are valleys carved by phi itself, revealed through omega, kappa, and nu together. And now we are ready to move forward. Persistence across history is one thing. Next, we test a harsher demand. Can a rule survive changes of scale? Before we close, I will make the firewall actions clear, because persistence is not just a feeling, it is an engineering decision. If the tests show persistence, the license expands in three ways. First, scope widens. You are allowed to apply the rule across a broader range of omega rhythms, kappa samplings, and new contexts. Second, uncertainty tightens. Because many variations and many pipelines still agree, your error bars can shrink. Third, standing rises. The rule becomes a stronger default constraint that new claims must respect unless they provide a licensed reason to challenge it. If the tests do not show persistence, the firewall does not insult the rule. It simply changes the license. There are 4 actions. Action 1 is narrow. You keep the rule, but only inside the omega kappa nu region where it actually survived. You stop speaking as if it holds everywhere. Action 2 is downgrade to local fit. You still may use it as a practical approximation, but you do not call it a deep constraint of phi. You treat it as a useful tool, not a universal law. Action 3 is archive as transient. This is important for civilization. You record what was tried, which Windows W were used, which representations R were attempted, which pipelines pi were applied, what the resource limits were, and what kind of failure occurred. This prevents future people from repeating the same dead search with the same confidence. Action 4 is retire. If repeated attempts fail, you remove the rule from active use. You do not keep building on it just because it is familiar. Now, here is a simple listener checklist you can carry like a pocket tool. When you hear, "This is a law," ask, what is the scope in omega, kappa, and nu? What representation was used, and would another licensed representation still show the same constraint? What pipeline was used, and would another pipeline still converge? What is the uncertainty bound epsilon, and does the residual R stay inside that bound when method changes? If these answers are missing, the claim is not mature enough for a wide license. And now one small exercise. Choose one belief you hold strongly. Imagine an omega shake, a kappa shake, and a nu shake that would be fair tests. Ask yourself if the belief would survive. If it would, you have a stronger belief. If it would not, you have discovered where scope ends. That discovery is wisdom, not defeat. One last reminder. You cannot claim persistence by testing only one echo. A rule that survives only when omega is fixed, or only when kappa is fixed, or only in one new fact is not triunity persistent. It is a special case. The firewall respects special cases, but licenses them accordingly. And we repeat the axiom. Rules do not become real by elegance, consensus, or tradition. They earn a license by surviving falsification, variation, independence, and scope discipline. If you want to see the full mathematical derivations and exact equations behind this idea, you can search for Holophase on Zenodo. There you will find the scientific papers that this audio journey is built on. Salam and peace be upon you.